For this parametric equation, x equals t squared minus 3 and y equals 2t, you're given a range of t values. So I'm just going to use those to actually plot my graph. So I'm going to make a t, x, y chart. And I'm going to start with t equals negative 2, go to negative 1, 0, 1, 2, 3. And I may or may not do all of these values, but when t equals negative 2, you go up to your x equation. Negative 2 squared is 4, minus 3 is 1. When t equals negative 1, we have negative 1 squared is 1, minus 3 is negative 2. When t is 0, your x value is negative 3. When t is 1, you're at negative 2 again. When t equals 2, we have 2 squared is 4, minus 3 is 1. And then when t equals 3, we have 9 minus 3 is 6. For my y values will be double my time. So a negative 4, negative 2, 0, 2, 4, and 6. So the next thing I'll do is actually plot these points, but I'm going to pay attention to the order that the points are going in. So my first point is 1, negative 4. My second point is negative 2, negative 2. My third point is negative 3, 0. So I could actually start drawing my curve this way. The next point is negative 2, 2, so it's symmetric to this one. 2 to the left and up 2. The next point is 1, 4. And then the very next point is 6, 6. Out here. So I'll finish the curve that way. I'm not going to put arrows on either end because the function does not continue out that way. We are restricted by these t values. So I am going to put directional arrows. I know that I was going in this direction as my t values increased. So the next thing I'm going to do is actually eliminate the parameter, and you have a couple of choices here, but you can solve for x or you can solve for y. In this case, having an x equals is actually easier because y is equal to 2t. Actually, it doesn't matter, but let's say t equals y over 2. I will take that and I'll plug it in over here. So I have x equals y over 2 squared minus 3. When I square this, I have a y squared over 4 minus 3. X equals that multiplied by 4, and I have 4x equals y squared minus 3. And then if I'm going to write it just implicitly, like put the y squared over here, so I have 4x minus y squared equals negative 3. Now, this is just the equation, and I left the y squared in, and I like the y squared in it because when we have y squared, that's when you don't have functions. So this is a parabola because the y is squared, the x is not, and I know it's in the x direction because of that y squared. So the next thing you have to do is figure out, well, how do I actually make just this piece of the parabola? And if you try to limit your x values, you're in trouble, because if you go from negative 3 out to 6, you would actually finish the parabola down here. But on this one, if I limit the y values, I can do it, because if you imagine it's a function on its side, it's absolutely not a function. It doesn't pass the vertical line test, but if we turned it over, it would. So my y values are all only appearing once. So I would say that, and again, you could have this as a y equals function, you could have an x equals function as long as you're correct. And then I'm going to restrict the range on this one. So I'm going to start with a low of negative 4 is less than equal to my y is less than equal to the highest value we had was 6. And that would be the equation with the parameter eliminated, or rather one version of it.